This is Intro to Section 4.1. This is Part 2. First thing we're going to go through here is a little review of the first part of this section, where we're matching up some sides and some angles. So in each one of these, what I want you to do, again, pause the video and see if you can come up with these answers correctly, and then I'll go through them, and then, again, if you can come up with them correctly, then you're in pretty good shape right now in understanding how to match up corresponding sides and angles. Okay, now that you've paused the video and you've went through and answered these, let's go through and match these up. So letter A, QX would be congruent to NY, segment NY. Again, first two letters and first two letters. First two letters on the left and the first two letters on the right. Angle Y would be congruent to, angle Y is the second letter on the right side, so the second letter on the left side would be angle X. Okay? All right, segment TA, again, the order does matter. So TA goes third letter to second letter, so on the left side. So if on the right side I have to do the same thing, it would be R and O, segment RO. And then angle R is the last letter on the right, so it's going to match up with the last letter on the left, which is angle T. Okay, and then the last set here, angle U is the second letter on the right, so I need the second letter on the left, which is angle A. And segment DB is congruent to segment, in this case KL, last letter and first letter of each. Okay, and then the last one, they've reordered NDBA, so they've taken the third, fourth, and then 1, 2, so 3, 4, 1, 2. Again, if you look at it, it's 3, 4, 1, 2 on the left, so I have to go 3, 4, 1, 2 on the right. And it would be C, K, L, and U. Okay, just kind of a quick review of covering what we did yesterday. All right, next, let's take a look at what we call the third angles theorem. We're going to put this in your tool belt. The third angles theorem talks about if two angles of one triangle are congruent to two angles of another, then the third angles are congruent. So as you look at this picture here, you know that D and A are congruent to each other. That's one pair of angles. E and B are the other pair of angles. Those are congruent to each other. So what they're saying is, if two angles of each triangle are congruent to each other, we can then say that the third angles are also congruent. So C and F. So if you wanted to, you could mark this with 3 marks here and 3 marks there. So C and F then are congruent to each other. Okay, the third angles theorem. So if you know two angles of the triangle are congruent to two angles of another triangle, then the third angles are congruent to each other. Okay, next is the proofs, and you're going to see a lot of proofs over this unit. Okay, so here's what I want you to do. I've got some filled out here with the first proof. I want you to see if you can do that one on your own. Okay, and then I'll go through it, and then we're going to go through the second one together. Now, a couple things before you go through these that I want to clarify and look and kind of show you what you're trying to do on these. On these, it says here, the given, it gives you a couple of segment lengths and a couple of angle lengths, and they're marked here in the picture, okay? And it says it wants you to prove that two triangles, triangle LMN and triangle LON, the top and the bottom, are congruent to each other. Well, how do you show that triangles are congruent? That's the question, okay? To answer that question, you have to show that all of the corresponding angles are congruent and all of the corresponding sides are congruent. Now, you'll notice there's some things that are missing here. And whatever is missing is going to need to go into a statement for your proof. Okay? It's going to need to go in a statement for your proof. So, as you look at these, what you're trying to put in your proof is that all the angles and all the sides are congruent. So whatever is missing from the given, you're going to have to put in your statements. Okay? So that being said, I'm going to pause. You should pause this and see if you can try and figure out this proof here on the left. I've given you some statements and some reasons, okay? And then see if you can try and figure that out. And then we're going to walk through the second one together. Okay, now that you've hit pause on the video, you've tried this proof, okay? the very first thing we're going to do here is we're going to go through the very first part, and again, the first step here is pretty easy. That's the given. Okay? All four of those things are given to us. All right, now the second step is the third angles theorem. That's the reason. Now, if you remember the third angles theorem, it says if two corresponding angles of a triangle are congruent to each other, then the third angles are congruent to each other. Now, if you look up at the picture here, you can see that we have M and O are congruent, and then MLN and OLN are congruent to each other. So we've got two of the three angles. Well, if we have two of the three angles, then we can say that the third angles are also congruent to each other. So I can say that this angle right here would be congruent to this angle. Now, the big thing is you have to be able to name them. Okay? So, when I go back and I look here at my reasons, I have to be able to name this angle and this angle. And I have to name them properly, and they have to be in order. So I'm going to name the first one. We're going to name the first one angle MNL. Remember, on the first one, it doesn't matter how you name it, as long as N is in the middle. So I went M to N to L. So I went one angle marking to three angle markings to two angle markings. I have to do the same thing on the other one. So I have to go 1 to 3 to 2. So the other angle is angle ONL. And they're congruent to each other by the third angles theorem. Okay? Now, as you look at the picture, the one thing that's missing is the middle line. The middle lines are not congruent in this case right now yet, but we said a reflexive property. Now, you'll notice as you look again, this middle line doesn't have a marking on it. Well, they both share this middle line, so therefore, in each triangle, if they share it, they both have the same thing, which means that they're congruent to each other. So reflexive property, I'm going to say segment LN is congruent to segment LN. Remember, you have a mirror image. It's the exact same thing on both sides. And I'm going to mark this in the picture. Every time you put something down, always mark it in the picture. Now, are all the sides corresponding and all the corresponding angles congruent as you look at this picture? Well, yes, they are. We've got everything marked. So now we can say that the triangles are congruent, and this is a new one. So you may not have gotten this one. And the reason we can say that the triangles are congruent is because the definition of congruent figures. Okay? The definition of congruent figures. And we're going to put that in our tool belt as well. Very similar to definition of congruent angles, definition of congruent segments. Okay? It's not a matter of us going from equals to congruent now. We're able to say that it's the definition of congruent figures because congruent figures means that all corresponding parts are congruent to each other. Therefore, the shapes are congruent to each other. Okay, so that's the first proof. Let's move it on over here and let's take a look at this second one. Okay, now, in the first step, we have all of our givens. So we're going to go ahead, we're going to put that down. They want us to prove that the triangles are congruent to each other. So we have to show all corresponding angles and corresponding sides are congruent. Well, if you look at the picture, okay, you'll notice all the sides are already marked. So we're not going to put any more sides. We're missing two angles. Okay, we're missing two angles. Now, so the first one I'm going to look at, you'll notice that these two form an X, which means if you think about it, these angles in the picture right here are equal to each other. Why? Well, they're vertical angles. But now I can't just name it angle B though. Okay? So when I name this, we're going to name the first one angle ABE is congruent to angle. If I go ABE, I went 1 to 3 to 2. I have to go 1 to 3 to 2, so it's going to be DBC. And why are they congruent to each other? Because they are vertical angles. So vertical angles are congruent. Okay, now I've got two of the three angles congruent to each other in each triangle. Well, if I know two, I can say that the third ones are congruent to each other by the third angles theorem. So I can say angle E in this case, I only have to name it with one letter because there aren't multiple angles there. So angle E is congruent to angle C by the third angles theorem. If I know two, then the third one is congruent. Okay, now the last step here, you'll notice again, now we have all the angles and all the sides that are corresponding are congruent to each other. So now I can say I want to prove that triangle AEB is congruent to triangle DCB because the definition of congruent figures. I've shown that all the sides that are corresponding and all the angles that are corresponding are congruent. Okay, this concludes section 4.1 part 2. Make sure you complete your WSQ when you're done.